Okay. Okay. So I think many of you might remember Bob Parks from I think it was 2010 last time you came here, and I keep running into Bob at the Tomcats Air Show, where he flies his rocket glider, and I always say, okay, what's the next topic, you know? And this time he came and he said, well, let's see, it's a Red Bull had a contest where they had to jump off a platform. I'm thinking, hey, you can talk about anything, Bob, we'll listen to it, but this might be on the lunatic fringe. But we're going to take him up on it because 4 years ago he talked about human-powered flight and about the Icarus flight from Crete to Santorini.
Icarus didn't make it.
Okay, yes. This is
Daedalus.
yeah, Icarus was the how not to do it.
Yeah.
So, I mean, we found that flight, that talk so interesting, but I've looked up about his background. He's worked at Lockheed, at Skunk Works at Lockheed, you might have heard of that, and has a, a MS and a double E in aeronautical engineering, and just been a terrific person in our hobby and area. So I thought, what a great thing to talk about how they did. You can find out if they won the Flugtag after the end of the show. So let's give a little round of applause for Bob and Zach.
Just a little bit of background. Zach and I both work at a startup company near here called Z.Aero, and that's about all I can tell you about Z.Aero. We're rather proprietary still. You might find interesting things in a Google search. But anyway, a little bit over a year ago, one of the guys that we work with came up with the idea of let's do something for Red Bull Flugtag. And once we get into this, you'll see what is typical for Red Bull Flugtag, and I think that's sort of what he had in mind. But he made the mistake of bringing it up with us, and we're both airplane people. And so it's like, okay, we're going to go win this thing. And so the title of this is Delaying the Inevitable by 10 Seconds. And what's inevitable? Next slide. Well, oh boy, that really blew the formatting. Oh well, we'll survive. What's going to happen is you're going to go into the water, and after you go in the water, they will take it out of the water and they will do that to your airplane. That happens to be our airplane. They grab it with a big front loader, crunch it up, stuff it in a dumpster, and it goes to the dump. So the only way, once you're committed to go off the platform, the only way you can delay that a little bit longer is you go farther and stay in the air longer. So we did. We got about an extra 10 seconds compared to everybody else. And if you're going to do all of that, you might as well get the world distance record while you're at it. Next slide. So what is Red Bull Flugtag? It emphasizes a couple of things: showmanship, creativity, distance. We emphasize the distance there, but they're really sort of equally weighted. The scoring system is sort of arbitrary. Anyway, the basic concept is you have this platform out over some water, and you shove things off the edge, and some of them actually fly. And in the extreme case, there's this one event in Japan called Birdman, and it's been going for like 30 years.
Not associated with Red Bull.
Yeah, not associated with Red Bull. And you get these very exotic airplanes, some of which fly for 20 miles. Some of which crash creatively. Anyway, next slide. Okay, so this is just a Red Bull summary video before... this was put out before last year's events. So a lot of it is falling with style.
Red Bull didn't invent this type of event either. On the previous slide, the top right picture was England in the 1970s. They claim it began in 1992, but...
Well, Red Bull Flugtag did.
The Red Bull one did in 92.
Isn't it all the way back to Lilienthal, trying to do the experiments on the steamers?
Well, they were trying to work. A lot of these are obviously not trying too hard to work.
Yeah.
Question.
Yeah,
Aren't you supposed to have some sort of showmanship when you're launching?
that too. There's what you do before you launch, there's how creative your craft is, and we'll get into that a little bit later. But these can be really big events. The one that we were part of in Long Beach last September was about 110,000 spectators.
There's a skit section that's 30 seconds where you have to submit music, they'll approve the music, and then you have to go through your pre-programmed skit. So we had a choreographer for that.
So some of them make attempts at flying. Some do a little bit better than others.
A lot of the ones that make an attempt at flying don't make the highlight reel because they don't look as interesting.
The judge.
Some of the skits are better than others.
You get extra points for spinal compression.
There's a lot of wires.
So the points given for the airplane or the body, whichever goes farther?
It's actually measured to the pilot's head.
Oh, to the pilot's head, okay.
Yeah.
The waiver is like a phone book. There have been some serious injuries in years past, and most of the rule book is written as a direct result of those injuries.
And we really think that the rules are different for each event they do.
Hey, check it out. Hey.
B-25.
Yeah. Ooh.
So this was 2010, and it was set the world record at that point with 209 feet. No, they don't. I think this is older than that.
Yeah.
Okay. So this is sort of the historical background. Next slide. Okay, so what is this to actual airplane engineers? Well, it's a glider contest, and they give you an extreme span limit, which was 28 feet in our case. And we think the Europeans might get 10 meters, which is significantly more. And you guys all know the difference between 2 meter and open class. Span is good. They limit you on how you can launch it. There's a lot of limits there. A lot of emphasis on the show. A lot of emphasis on Red Bull. So we had a 28-foot span. Previously it was 30. That may have just been for Long Beach. There was a weight. Everything that went off the platform was limited to 400 pounds, including the pilot. The pilot couldn't go head first. That used to be okay. You couldn't have any harnesses to hold the pilot in the airplane. That also used to be okay. They did have a case of somebody getting trapped underwater for a little while. No stored energy pulleys, ropes, bungees, high starts, pyrotechnics, all of that used to be okay too. So the rules just keep getting tighter and tighter. Anyway, next slide. So this is how we got involved. This is us at work. And this was the fateful email saying, we've been accepted. You have to apply to Red Bull. They take, what was it, about 28 teams, I think it was, for Long Beach. And I don't know how many applications they get, but a lot of people get rejected. So they're mostly looking for somebody who's going to be a good show. And they're looking for how are you going to get them exposed on social media, all sorts of things like that. Anyway, so if you look at the date on this, it was June 7th, 2013, late afternoon. This is about 100 days before the event. So, next slide. So this is actually a screenshot of our page on the Red Bull website. Each team had their own page. You got to put your stuff up on it. This was the sketch that got us into the contest. You had to do a sketch and a video and say who the team was. There's 5 official team members, one of whom is the pilot. 4 other people on the platform. The people outside of that group can be as many as you want, but there's only 4 on the platform. So our pilot here was Laura Shane. She's a mechanical engineer at Z. Did a little bit of hang glider experience, and as you can see in this picture, she wasn't too concerned about jumping off a tall platform. So, next slide. So first step when you're going to do something like this is, let's go figure out how not to do it. So you go to YouTube, bring up all the videos, and once you get past all the things that have no chance at all of flying, they're just falling with style, then you get into how do the ones that people are sort of trying to make work, how do they not work? Well, the first one is structural collapse. Some of them fall apart before they go off the edge of the platform. Some of them, as soon as they start to take any air loads, they fall apart. Then there's the ones that are so flexible, the wings fold up, the tips touch, the wings twist off, whatever. Then you hit a lot of airplanes where they haven't figured out that the CG matters on an airplane. This is things you look at the airplanes like, okay, the CG's in back of the trailing edge of the wing. This is not going to fly very well.
To which they say, what's a CG?
Yeah.
Yeah.
So you have this really nice airplane, the pilot's sitting halfway back in the tail boom. Then, once you get sort of stable, then you've got things that are out of trim, not controllable. If you get somebody who's really good, then you get to the point of no lateral stability. They sort of can fly in pitch, but they just roll over and dive in. And then there's a pretty common one, not launched fast enough. They go off the edge of the platform, they're fully stalled all the way into the water. And I don't have a video of this one here, but this was a really good airplane at Flugtag in San Francisco in 2012. Very gorgeous airplane. They had a nice launch cart. There was a pin that held the airplane to the launch cart while they were off doing their skid. They forgot to pull a pin.
Oh.
So they go off of the platform, leap with the cart, and ride the cart all the way into the water. They still got second place for distance, though.
And that was your first try at helping a team.
Yeah, that's true. I didn't talk to them about it.
We were your redo.
Yeah. So anyway, we knew not to do that one. Okay. So the first step, what do you want to do for an airplane if you want somebody to actually go some distance? So we started out doing some tests out in the parking lot. We took one of these little utility carts with the cast ring wheels, got some people pushing it, timed how fast they were going, and it's like, okay, 15 miles an hour is about it. It's pretty easy to get to 15, really hard to get past that. So that's ground speed. We obviously don't know what the weather's going to be. Long Beach, September, probably pretty good. But might have a headwind, might have a tailwind, but you get what you get. So if you look at 15 mile an hour ground speed and say 15 mile an hour airspeed, 28-foot span with the weight of this airplane with a human in it is really huge induced drag. You really want more span or you want to go faster. And if you go figure out what that airplane would be to fly at 15 miles an hour, you end up with things like 15-foot chord on a 8-foot span. Not likely to do too well. So the first thing is, okay, we're up high, we can come off the platform, we can dive a little bit, get some speed, pull out, and go from there. So what's the best way to do that? And what works out the best? So you start crunching some numbers. Next slide. So the past history of this, you saw a little clip of this flight. This had the record in 2010. They had a tall platform. It was at least a 30, well, you can see over here how big the people are relative to the platform height. They had a tall platform, and then they had a really tall cart. We think the cart was about 15 feet high. They do this big dive. They barely miss the water. They pull out. They're pitch oscillating all over the place. But they went 207 feet. And we're looking at this, and it's like, okay, we know we can do better than that. Next slide. So here's a video of that. Notice how tall their platform is. They give it a pretty good push. They get their pull out. And there they're pretty stalled, but that marker buoy was 200 feet. So that set the world record in 2010.
Female pilot. is a tradition in Red Bull. We adapt that.
Okay, next slide.
Did they know what they were doing, or did they luck into that?
They pretty much knew what they were doing. The group of people who did that were associated with, I think it was a general aviation FBO. So they were aircraft mechanics and pilots. So they had a pretty good idea what they were doing. Okay, so the goal here is you've got potential energy in your altitude. You're going to drop some of that altitude to turn that potential energy into kinetic energy and glide speed. And so you say, okay, I'm dropping 5 feet, that's so many foot-pounds of potential energy, and I turn that into extra forward speed, and now I'm instantaneously in a nice glide at that condition. And you can do some simple analysis of the airplane, get a lifted drag ratio, and that tells you how far you can go. So this looked pretty good. It's like, yeah, we can do way better than Miss Mitchell. Miss Mitchell was the B-25. Okay, second step. Obviously, you can't drop and instantly pull out. So you take an airplane, it's got a glide polar, you've got to hang a sort of an automatic airspeed controller around that to pilot the airplane to try to make it fly the flight path you want. And you specify what lift coefficient, and you go figure out, okay, what's the best way to go a good distance? So this was the first look at trajectory where you've got both a vertical speed and a horizontal speed. It's what's called a point mass model. There's no inertias, there's no control surfaces, but it's got to make lift to do the pull out, that kind of thing. And boy, this was a lot less optimistic. And so now the attitude is, well, maybe we can do a bit better than Miss Mitchell. So here's a couple plots of that of the simple case. Now, Red Bull all along said, okay, the platform is 30 feet high. Okay, and one of the rules for Long Beach said the whole airplane, pilot, launch cart, everything on top of the platform could be no more than 10 feet above the platform. So that was getting rid of these 15-foot high carts with 10-foot high airplanes on top of them. So, okay, we're immediately at a disadvantage there. And, okay, so we go look at this, and here's a typical trajectory. You pull out, you got to overshoot back up again. You settle into a nice glide in 250 feet. Here's airspeed. This was probably actually assuming a little bit of a tailwind or headwind or not pushing too hard. Tailwind, sorry. So you pick up speed, and you really want to be flying at about 20 miles an hour, but you overshoot, you go up to 24. But hey, 250 feet, still pretty good. Next slide. So this is a little bit of a complicated result. This is what happens when you include wind. So these are wind speeds. This is 0 wind. This is a 2 mile an hour tailwind. This is a 2 mile an hour headwind. So 10 mile an hour head and tail winds at the edges. And it's looking, you're going to build the biggest wingspan you can. So this is just varying the aspect ratio. How much wing area do you have? So at the low end aspect ratio of 3, it can fly at really low speed, but it's really poor glide. And if you notice all of these curves, they have this big drop off. Well, this is where you're trying to pull out, and before you can pull out, you hit the water. So these are really nice flights up here. These are what happens when you blow it. And all of these things are about 50 feet, which is what happens. You come off the platform at about 15 miles an hour, and you go right into the water and you go about 50 feet, which is not that much different than the ones that just fall off the edge. So you look at these, and if you have a lot of tailwind, well, if you've got aspect ratio of 4, you can sort of hold it together and you can fly with that big tailwind. That's not the best airplane you can do if you've got a headwind, but the ones that work really well with a headwind don't work at all with a tailwind. So this was a trade-off that you've got to go figure out. Okay, next slide. So the final step, as you guys know, you can't instantaneously change the pitch of an airplane, particularly when you've got a big airplane. You're only, airplane's 15 feet long. You're doing a 30-foot drop. The size of the airplane is significant. There's a minimum radius it takes to turn. So this was a fancier simulation that included all of the pitch rotational dynamics. So you're looking at what is the elevator positions, how does the airplane accelerate in pitch, and it turns out that you've got very fast pitch rates, significant angle changes in flying just the length of the airplane. You need huge elevator deflections. You're maybe rotating so fast that the normal simplified dynamics analysis you use on airplanes doesn't apply. And the other thing that we found is the initial angle that you set the airplane on the cart was very critical to how much altitude it took to do the pullout. But it could work. Anyway, next slide. So this is what the airplane looked like at that point in time. Pretty low aspect ratio wing with winglets. Because of the height constraint, the winglets went down instead of up. And it was an H-tail that was also because we had the limited height. You don't want to extend too far down because you hit the water sooner and you're limited how far up you could go because of the 10-foot rule. And we had a really simple little hand-toss model that said, yeah, this thing can fly. Okay, next. So this is launching at 15 miles an hour, coming off the platform 34 feet up. We figured that was basically, we could have 4 foot of cart and 6 foot of airplane and to meet our 10 feet. And launching off the edge level, one of the things that happens is you come off the edge level, you're sort of doing this and you're mushing for a bit. You lose some altitude while the airplane can trim into the direction it's going in the dive, and then you have to rotate it back out to pull out. So now all of a sudden our distance is about 175 feet. So not as attractive as Miss Mitchell. Now we're launching from a lower altitude. They were probably 45 feet off the water. But hey, this is what we expected to get. Next slide. Now, this was actually kind of interesting when we figured this out. If we actually rotated the airplane 10 degrees nose down, then you waste less time getting it to pitch over, and you can accelerate faster and start pulling out sooner. And hey, we're up at 240 feet. This is the same airplane, just changing the angle. The problem is when you rotate the airplane, it gets taller because you just shove the tail up. So we were thinking about this a lot and looking at options on it. And next slide. Oh, by the way, we were using up our 100 days while we were doing this. So one of the things that comes out is all this is low altitude. What about ground effect? And doing ground effect, skimming the water, requires relatively smooth water. They're pretty good piloting, and hey, you don't get a whole lot of practice time here. And back in the Daedalus Human-Powered Airplane project, we did a lot of work looking at ground effect, trying to find the best cruise altitude. And we found for that airplane, in a bunch of very careful measurements, this was data from a bunch of flights at Edwards Air Force Base, that the drag should have gone down as we got closer to the ground. This is an altitude fraction of the wingspan. The power required should have gone down as you went closer to the ground, but if you fit a curve to that data, it slopes the wrong way. So the basic feeling on that is when you have a really slow airplane like a human-powered airplane, as you get closer to the ground, you also get more small-scale turbulence. And when you have a slow airplane, a little bit of turbulence gives you big angle of attack changes down the wing, and that hurts the drag and overcomes the ground effect. So this is a faster airplane than Daedalus was, but based on this, we decided we just weren't even going to look at ground effect as part of these traits. We were going to design as if it wasn't there, and hey, if we got it, we got it, and that's even better. Okay, so the conclusions out of all of this, a lot more respect for Miss Mitchell. They really did a pretty good job with that airplane. It's a complicated maneuver. You need lots of elevator authority to rotate the airplane quickly. And there's no good way for the pilot to practice that. You don't want to take one of these things up really high. Where are you going to find a cliff to go off of? that you can try these things. And if you do it wrong, then you probably wreck the airplane, maybe wreck the pilot. So really tough piloting. And even if you get it exactly right, you've really excited the phugoid mode. You guys are all familiar with that when you get the sailplane that just wants to keep stalling. That's a phugoid oscillation. And so it's hard to do this radical pitch maneuver and then instantly get a clean glide. So everything we looked at needed at least 20 feet of initial dive, and so we're sort of saying this is not a great idea. So the reality, we got, a week before the event, a friend of ours was down in Long Beach. He takes a look at the platform and says, there's no way that's 30 feet. We measured it from photo interpretation, and it was probably 20 feet, maybe 21 feet towards the end of the contest when the tide went out a little bit. If we would have done any of those dive and pull out airplanes, we would have hit the water. And even if you did manage to pull out, well, okay, you're nice and gliding, you're 1 foot altitude, how far can you go? So several weeks into it, we said, forget all this, it's time to change. And so the other approach is what we'll call a two-stage launch. The ground crew pushes a big cart, which is basically a runway, and it turned out the size and weight of the cart wasn't too critical on how fast you can push. You could still get 15 miles an hour. Then the pilot runs down the moving runway, gets another 5 to 8 miles an hour, maybe more. And then now we can design the airplane to fly at 20 miles an hour, and 20 miles an hour is a lot better than 15. You just cruise off the platform in level flight, simple and easy to pilot, and you can even go practice it off of a hang glider hill. So this means inherently a foot launch type airplane, a hang glider kind of thing. So in 2012, somebody did basically that in Germany. They broke the Miss Mitchell record of 209 feet with a flight of 229 feet. So, next slide. And here's a video of that flight.
Were they running on the top of it?
Yeah.
It's a two-stage launch.
So it's a
So,
two-stager with the
crazy high, flimsy cart.
Yeah.
Wow. Prop designers, they had a huge shop, and I watched their blog when they built it. It's absolutely beautiful, really, really well built. Someone knew something about flying wings for their airfoil and twist choices for sure.
German.
Yeah, I think everybody knows that. German.
Now, they're not working too hard on pushing here, but the cart might have fallen apart if they did. They still had to dive and pull out a little bit. And here he finds out that rigid hang glider wings don't work laterally, but hey, he made it a long ways first.
Yeah. In a head-down harness.
Yeah, so with a harness, face first, but they did 229 feet. So this was the record at the time of when we were doing our airplane.
About 6 rules that you couldn't do, right?
What's that?
About 6 rules there you guys couldn't.
Absolutely. Now, that doesn't mean that the next one they have in Germany, they won't be able to do it. But for what we did, Long Beach, it wouldn't surprise me if they get 10 meter span instead of 28 feet, and hey, span is good on basically span squared that counts. So 33 feet is a whole lot better than 28. And of course, they had a 15-foot high cart on was probably a 10-meter high platform. So they were launching 45 feet up. And they got harnesses and whatever. So after all of that, we had a strategy. Okay, we're going to fly off the platform in level flight. And so we had to then actually go come up with a design. And okay, so now it's Zach's turn to talk.
Yeah, so I was, is lucky the right word? Lucky enough to sit across from or next to Bob during a couple of my years at Z. They recently moved me across the room from you. But
I saw what could happen.
yeah, I guess so. But I'm a hang glider pilot for the last 4 years, and been flying RC since I was about 16.
He's also very big into flying wings.
I'm a flying wing guy, and it's a bias I admitted when I pitched ideas.
Yeah.
And have a BS and an MS in aeronautics. So yeah, I think we've laid the background for what our design criteria were. I'll just give away our answer first and then talk a little bit why it ended up looking this way. So the aspect ratio, which is the same thing as the area pretty much with the span constraint, came from that initial study Bob showed where we decided we wanted to have a plane that would fly, be able to pull out if we had some tailwind, but also not suffer too badly into a headwind. And the span efficiency number was something that we were really looking to improve with our winglets, so that the plane could essentially, act like it had a bigger span than 28 feet. And we think we did about as good as you can do with this box we were given. We had to play a lot with the dihedral because we have massive anhedral effect, and we didn't want it to be totally unsteerable. Because that's complicated by the fact that you have a low CG on the aircraft and weird dynamics from low aspect ratio. The sweep gives you some anhedral effect, so all these things came into play, and this was kind of our compromise between handling and efficiency. So, as I mentioned, winglets were important for reducing the induced drag since we knew we were going to be flying too slow. That is, this aircraft would be capable of getting a better elevator at a higher speed, but we probably weren't going to be able to fly at that optimum speed because we'd have to give up altitude to do it, and it's a net loss to give up altitude to go to your best glide. So we're flying on the back of the power curve with tons of induced drag. Obviously, they help with our yaw stability, and we could steal the Icarus 5 twist grip rudders where you have one rudder kick out on either side, and that's your yaw and your roll. The roll works out pretty well because the lift distribution kind of spills over the winglet. So if you wreck the lift out on the winglet, it kind of wrecks the lift up on the wing too. The other nice thing about downward winglets is instead of superimposing all this high suction on the top of your wing right next to each other and asking all that wing to suck right there and not separate, instead you're just asking for all the high pressure area to be sort of condensed, and so that's an easier aero problem.
Also easier to build.
And easier to build. Next slide. We were wondering whether it mattered with ground effect, whether the winglets went up or down, keeping in mind that we weren't sure whether or not we'd see any ground effect from piloting.
This plot was actually done after the event.
Yeah, when we were really curious. And what the plot shows is that we were going to see a benefit in ground effect from a vortex lattice model, whether we were near the water with winglets or without. So this analysis method didn't show any benefit from sort of this idea of trapping the air into the water.
Actually, it does, because if you look at it, the induced CD of 0.02 at 5 foot altitude versus almost 2.5 times that without the winglets. So down winglets work definitely better than up winglets if you're trying to get ground effect.
But the relationship of how you get your benefit from being close to the ground is about the same. So, yeah, I'm giving Bob credit for putting height on a horizontal axis, but this would be your height. So if you turn this side, as you get lower and lower to the ground, your induced drag falls and falls, and whether you have winglets or not, they both fall. Not having a tail was one less thing we had to build, which in the really short time period, we were all really stressed
Particularly
out.
after wasting a month trying to figure out what to build.
Yeah, totally. We thought we could get away without an elevator, so it's going to be lower part count, because now we could just weight shift for pitch. Again, like this hang glider design from the 70s called Icarus 5. I think we have a photo later. So no tail boom. And there was some precedent for this sort of thing. If we did have to do a pullout, there would be hopefully less pitch damping. So I had designed a lot of foam flying wings and even some composite higher aspect ratio flying wing sailplanes, but I had never dealt with having this low CG. It's not something RC prepared me for, and it has a really weird effect on stability. Paragliders exist because of the pendulum stability effect, which is close enough for how it works. And I think on the next slide, can you try one more? Oh, this is an older version. Well, if you go back, I had the colors inverted. It's fine. We'll just skip that. I'll just leave by saying the pendulum effect means that your pitch stability depends a lot on how fast you're flying. So you can design for one design point, and when you get off that design point, you could be incredibly overstable, where you'd have a lot of trim drag, or you could be unstable, depending on how you choose things. So, and I guess it's worth mentioning the airfoil you saw was kind of derivative of a Mark Drell airfoil that he had designed for a hang glider, though I don't think it ever got put on anything.
I'm not sure what it was designed for.
Yeah, but it looks a lot like an HPA airfoil that someone bent the trailing edge up. Yeah, someone added some reflex to it. And we played around with reducing the amount of pitch stability we saw from the airfoil because we could get more efficient airfoils if we allowed them to be pitchier. So the other thing I'll just say about doing a swept flying wing that I beat myself up about when we went to build is just keeping everything straight, coming up with jigs, because the wing is sweeping and twisting, and so getting everything lined up, even at this big scale, you guys are used to working on a lot finer dimensions. We had big tolerances, and it was still a really hard thing. We were all wishing we could have just done Hershey bar wings, where you just go rip, 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 rip. We were all really happy we did constant chord, though. That was not an aero efficiency choice. That was just to make the build easier.
Fewer root jigs to build, right?
Yeah.
Yeah. So one of the interesting things on this, since it was aspect ratio 4, there's sort of two ways you do flying wings. If you have a swept flying wing, you often do it with cambered airfoils, but with wing twist, in order to get your pitch trim. If you do a plank, you've got to do it with reflex, and we were sort of somewhere in the middle, so we had both twist and reflex. And we did a fair amount of analysis to figure out that just how much of each was appropriate.
And also a little bit like a paraglider.
Yeah.
Some of that stability thrown in for fun.
Okay, so for the structural loads, the first thing we had a little bit of a structural design issue. Zach here was our by far most experienced hang glider pilot. You're how heavy?
230.
Now, since you're span limited for the event, you want to be very light. So we had a very light pilot, Laura, who's about 130, who's going to be flying the airplane in the contest. But all the structure had to take care of Zach. And a test flight with Zach, where you assume that, okay, maybe things are going to be a little bit iffy and it's may not land exactly nice the first time. So we took the aero analysis models, we extracted the lift distributions and things from that. And then we had to design for a heavy pilot. We went with a really large safety factor. If you don't have time to do it right, you just overbuild. So quick manual calculations on all the critical parts. You trade a little bit of weight for a lot less analysis and faster build time. And then a general rule of thumb when you're trying to do something like this in a hurry, and we're now down to less than 2 months, the lighter the part, the bigger the margin you put on it when you design it. So, all the little fittings had safety factors like 2 pi, something like that. Anyway, the Flugtag rules assume the craft is going to crash into the water. Now notice the little asterisks there. We were really puzzling about this in the rules until finally we figured it out. When they say craft, they mean arts and crafts. It has no resemblance to aircraft. Anyway, they emphasize pilot safety for good reasons. They assume the airplane's going to crash. They assume it's going to go, very quickly and steeply into the water. So no wire bracing around the pilot that they could get trapped in. No structure in front of the pilot that they might hit when the airplane hits the water. The pilot should have a direct way out, which is assumed that the airplane stops when it hits the water and the pilot keeps going out the front. And the height limit meant that we couldn't have a king post on the top to help handle the downloads. So all of those had to be taken as bending moment or compression loads which is a lot tougher than wire bracing off of the strut. So we were relying a lot on prior art from a bunch of 1970s fixed-wing hang gliders, and they all had bracing wires. They had structure in front of the pilot. The pilot was basically in a cage. Cage, you know, as soon as you say that in Red Bull, they think entrapment, not what they wanted to see. So here's some examples of prior airplanes. Obviously, Lilienthal up in the upper left corner. VJ-23 monoplane in the bottom right. And let's see.
Yeah, that's Terrace and Terrace again.
So Icarus 2 and Icarus 5.
5 and Easy Riser.
Okay.
Which is kind of derivative. And the bottom right one of the England Birdman rallies in the 70s. He flew something like 60 meters with no cart. So that was a really good plane. One thing we were looking at these is that you could hang by your armpits on all these designs, so you didn't need a harness, and you weren't necessarily head first.
Okay, so the basic structural concept, since you don't have time, off-the-shelf aluminum tubing for all the primary structure. You can buy it. It's very consistent. You know, it's an engineering material. So the basic procedure here was go up to Allen Steel in Redwood City,
I love that place.
stare at this big rack of aluminum tube, get out the calculator app on the phone, and okay, I know roughly, oh yeah, this tube has to take so many inch-pounds of bending moment. And you go through these tubes, and it's like, which is the best combination of diameter and thickness that was in that rack that would meet the loads? And then load it all up in the van and drive back to Z. Simple and fast, you cut it to length, it's done, it's nowhere near like making carbon tubes, and it's moderately cheap. We spent about $500 on tubing. The other part of the structural concept, as a lot of you know, I did a lot of human-powered airplane stuff in the past, and basically I ripped off all the details we could from this airplane, which was the MIT Chrysalis from 1979. So hot wire cut foam ribs with wood caps, bent foam leading edge sheeting, it was heat formed Depron, mylar film covering that was heat shrunk. We decided at one point we were going to cover it with aluminized mylar. It's like, you know, we're building this in a hurry, it's going to be really ugly inside. Let's hide all the glue blobs. Aluminized mylar is really hard stuff to shrink. Now, that was a mistake. Anyway, just a little bit on this airplane. It was a 72-foot wingspan airplane, 730 square feet of wing area, 93 pounds without the pilot. It was designed for about 4 G's ultimate load. It's a 2 ounce per square foot wing loading with no pilot in it, and 5 to 6 ounces with a pilot. And that was an all aluminum airplane. So the lack of structure in front of the pilot really complicated things. Normally you'd really like to have some structure coming down from the wing spar, which was ahead of the pilot, ahead and above. You'd like to come down from that and support these 2 rails the pilot was hanging from. But instead we had to do this really fancy laminated wood bent beam with the aluminum support rails. We had about 500 foot-pounds of bending moment in this little wood structure. It was a real pain to design it, a pain to build it, but the pilot really appreciated the ability to just go straight forward at the front when they were underwater. So this is just an overview of what the structure was. Off-the-shelf aluminum tube everywhere except for those wooden beams in the center. And the winglet spars were plywood. We had to go through a bend. The easiest thing was just bandsaw it out of plywood, call it done. Next slide. So this is just sort of the top view of the pilot support structure. So the rear spar on the wing was angled back to get behind the pilot. And then we had a bracing strut that was going up. It was in tension. So there's about 1,400 pounds of compression, I think it was, in that rear wing spar. And that gave us these kick loads that supported the weight of the pilot who was cantilevered out in front.
So that's a single piece spar? It must have been hard to put those kinks in there.
No, the airplane, you got to get it to the contest. It was in Long Beach.
Oh, okay.
So this chunk here is the center section.
Right.
This is the main wing spar. There is a pin joint here, and then in back, it's not really shown in this view, but there's pin joints just outboard of.
Oh, okay, so you didn't have to put the bends in there and
Right.
mess around with all that.
Yeah, all of that was taken out in the way that we did the pins to join it together. And there's some pictures of that detail later. You can talk about this one.
Oh, yeah, a coworker named Norio, who's an amazing RC pilot, he and I stayed a weekend and built a little subscale model of this. The main things we wanted to test were how does turning work with just the kick-out rudders, and what about this low CG business, and is weight shift a good way to do pitch in a design like this? And along the way, hopefully, we'd find out that it basically flies okay. So, Lemon, do you want to show this?
Yeah, I would show it like,
Uh-oh, we've yeah.
yeah,
It may or may not be okay to fly RC out there.
we won't tell.
Okay. But this is a couple iterations in of messing where the weight shift was. Part of the reason it's not more to scale is that in order to, we knew the real craft, we had some weight estimates, and we thought we knew where the CG would be vertically. Subscale, the way things scale in mass, we had to hang a servo with a battery on a stick to get it way low so that the CG of the entire aircraft weight shift system was about the same scale location. So that explains the ugly bottom, and the servo liked to strip gears every time we landed from inertial load of the weight swinging forward. And so we didn't fly this a whole lot, just enough to prove to ourselves that it seemed to be all right. It gives us a starting point on where to put the CG and how much scale travel, like how many chord lengths or fractions of a chord length you have to shift your CG to have effective pitch.
And really good for a warm, fuzzy feeling that it's going to work. Okay, this is roughly real time. We had to build this in Missouri by that point.
Did all that pink foam?
This room doesn't have ADA access, so our company couldn't use it for any commercial purpose, but there didn't seem to be a problem with us using it for recreation.
Which building is this? Picture one?
Yeah, and it's actually totally sealed off now, except for there's one key.
Gotta make sure you can get it out.
Yeah, this is also upstairs.
Oh!
So we had to go downstairs and then around a corner and out the front door. And yes, we did do a CAD model of the door and figure out that, you know, this was about the biggest cord we could get through there.
They got a wall and just fly out.
So this is just some pictures of the initial design. That's not a two-seat version. That's sort of the forward and aft CG locations.
It never occurred to me that'd be a joke, and every time I show people, here's the CAD image of the plane, they'd be like, what are they cuddling? Is it tandem? What's going on? No.
Okay, next one. And let's see, this is laser cutting the rib doublers. The hole is where the spar goes. So these go, the ribs are, you start with a piece of 2-inch thick foam, and you laminate on plywood rib caps with epoxy, and then you run it through a bandsaw and you take off slices, which is much harder than it sounds.
Get the straight cut, you get pain.
Yeah. If you're a little bit smaller scale, you do 2 passes with a circular saw. That actually works very nicely. Anyway, these are doublers that go on the side of each rib to get the loads from the caps into the spar. Let's see, over there is hot wire cutting winglets. This is a stack of heat formed leading edge sheets. And this is cutting leading edge sheeting. And that's a full-size wing rib. Next one. This is putting the doublers onto ribs. So they're just a template here, so you get them all the same. That's one nice advantage of constant chord. This is a detail of how we did the pin joints where the wings joined each other. We had these heavy aluminum straps that were drilled for the joiner rods, which were just music wire. They were bonded and with really fancy epoxy and rivets into the aluminum tubes, and you just had to be really careful to make everything fit right. There's a wing frame going together, more on a wing frame. This is a detail of the trailing edge. This is the rib coming in. There's some little doublers on the side of it. A 3/4 inch aluminum tube that takes the compression load from the covering tension in the trailing edge.
We had two wing jigs, one that held the wing vertically, which was Bob's awesome idea. Did you get that from an HPA?
Yeah, that's how we did with Chrysalis.
Yeah, it was great. Everything was, right here to work on. That was good for all the leading edge work and all the covering work. And then we had a lay it on the floor kind of jig where we had spacers to hold up the trailing edge to get the right washout.
So, when you're working on a very lightweight wing with a 6-foot cord, somebody, 7?
Yeah.
7-foot cord, somebody will reach over and drop something heavy onto your structure. It's guaranteed to happen. And if you do it vertical, it's not too bad. So this is the beginnings of the launch cart. This is the wing framed out. That's Laura. You don't get to make vroom vroom noises, but that's the disadvantage of flying gliders, I guess. And this is fitting up. This is the wing center section spar, starting to fit up the joiner fittings. So this is the center section coming together. That's Laura in it.
She almost fell through since it was sized for the tubes to be this wide so I could test fly it, and she's not quite as wide as me. But what she lacks in that, she has great lat strength, so she could just sort of hold herself there. She never complained. I'm sure it wasn't easy.
Laura was previously captain of the U.S. women's lacrosse team. She's rather athletic. And so here's the airplane almost all together, just before we were ready to take it on test flight. Next slide. And that's test flying. You can talk about that.
One of the big efforts that we had to do was to figure out how to transport this safely. Nothing would have been more disappointing than spending months and then having it all break when you go over a pothole. So a lot of effort went into fitting these wings, which they just barely fit in. This trailer is 8 feet wide. There's a lot of structure inside to hold everything, and it could all slide out into parts and then pin together with Bob's system. Training hillside is where I learned to fly hang gliders. Tends to funnel in pretty steady, easy winds. It was actually kind of gusty on the test flight day, and it was about a week before the competition.
It was a week before the competition.
It's exactly 7 days, yeah. And we were weighing the pros and cons of, half the team was freaking out, are we really going to do this? Because we're going to break it and we're going to go to Long Beach with nothing. And the other half of the team was, we're serious about flying. We need to, get it, learn a little bit about how this thing flies. So we headed down and spent the day down there, and I think we have video.
No, this is just a still photo at the moment. So that's Zach in it.
Does the video not make it in?
No, it's in there. It's not
okay. So yeah, I started and we progressively went further and further back up the hill, and 200 square feet, 230 pounds is just no big deal. These wheels we borrowed from the hang glider site. That's the base tube of a train glider, duct taped to the bottom of our tubes, so hopefully it would roll instead of shock load and break itself. Our kick-out rudders, we found out they worked, but we thought we had a turn in the glider, and we found out that we could overstress the rudders and break them. So we did a couple field repair of the rudders, and then later on we had to redesign the whole rudder structure. After I test flew the glider, we got Marshall, who's 155 pounds and about 2 years of hang gliding experience. He did some flights, and Laura, with about 5 days of hang gliding experience and 130 pounds, she did some flights. And with Laura, you saw how easily it lifted me up. With Laura, I ran beside her, and her feet were immediately over my head, with a gust, and and she was having a hard time steering, and there were a couple times where we could have really easily lost the airplane just in test. But she did a really good job controlling it. We also found out for Laura we had to shift her body position way forward.
Not surprising.
Yeah.
And just found a lot of other things.
We also found out it was really awkward to hold the plane before you launched it. It's incredibly heavy and it's very tail heavy, so it's always trying to fall backwards.
How much controlling was she actually doing during the flight?
Full rudder the whole way.
Yep.
Yeah, but in the video, it looked like a crosswind.
No, it was actually a bit of a headwind.
Oh, well,
A little head cross, kind of coming from
Yeah,
maybe
it seemed
30
drifting
degrees
to the
off.
left,
Yeah. But yeah, she kicked out the right rudder most of the flight.
Goodness, get close to the island.
That's a peninsula, actually.
Did you think about putting like little water skis on our feet? Because
We've talked about it, but
Bob really wanted to do a wakeboard. You were fishing on that one.
yeah. But once we got into realizing she had to run, you know, we got a little bit of a headwind, and you know, so she came off earlier than she might have, and we took advantage of that. So
Great.
So how far was it?
250. Well, here we go. Some after the fact analysis. We went 258 feet. So the blue is the records. However, the other guys had roughly 30-foot high ramps to launch off of.
Yeah.
They had 15-foot tall carts. We had 2. And throwing in a few other things just to make us look better. We went a little bit farther than they did, but we had a really big advantage in effective L over D.
You had to with all the handicaps you had.
Yeah.
yeah.
So, you know, when we saw that platform at 20 feet, we said, okay, yeah, we can probably go farther than anybody else here. And, but we didn't think we'd necessarily be able to get the record just because we were launching so much lower than the previous ones.
How far would you go if you had 30 feet and a 15-foot kite?
Roughly twice as far.
It's probably a good thing though, because I don't know if you saw the island.
Yeah.
You probably would have run into the boat.
Yeah, and if it
on the
hadn't
island.
have drifted off to the side, if you would have gone straight out, there's a big boat
Yeah.
that you would have hit, so.
And there were boats closer in for the team before us that went about 130 feet, and I just watched them sort of drift out of the way right before we got up. So a lot of things just worked out really favorably for us that we had no control over.
Conversely, the Red Bull people who were putting GoPro cameras on all the interesting airplanes didn't give one to us.
Oh.
And you're not allowed to have your own.
Oh, really?
They control all of the media.
Oh, sure.
So,
That's a killer L over D.
so particularly for aspect ratio 4, yeah.
And
Just somebody hanging down.
a chicken costume isn't the cleanest.
Yeah. So lessons learned, you know, practicality really wins. A big deal in all of this, our customer, meaning Red Bull, has a totally different perspective than we did. I mean, their rules were written by marketing people. You complain about like RC Soaring rules being, you know, who the hell wrote that?
And lawyers.
Yeah. And, you know, the rules just, you know, they're not even in good English. So, yeah.
Which we use to weight down gluing assemblies.
Yeah. Almost nobody in the team actually drinks the stuff. We didn't tell them that. One big thing was that, you know, empower people. We had a lot of people who wanted to help out who had never really done airplane construction before, model or otherwise. And so we got pretty good about getting them doing useful things.
Yeah, one quick story on that was the one team member who was really eager to help and always there and put in a lot of time. He designed our trailer that got everything to the the training hill safely and Long Beach safely, he and Bob were gluing wing ribs to the aluminum, and we had these the high-sol guns.
Epoxy guns.
Yeah, so Bob's going down and gluing all the ribs on, and he gets done and he's used about a third of a gun. This other team member who's really zealous used three like reloads. It was like a ball of glue each time.
Was that on the left?
And so,
And I was going through this saying, it's Flugtag, not an HPA, I can use a lot of glue.
yeah, Bob was the same movie. So, but we were happy to have people helping, and we weren't picky about those things, and we weren't going to let anyone see the ribs and stuff underneath the aluminized mylar. So, and if you could see the winglets up close, you would all cringe. Probably all far better craftsmen than we were on our winglets. They were ugly.
Anyway, you know, this was kind of a stupid airplane project that was still pretty rewarding. And we still don't have any good way of avoiding all-nighters. Next slide. But if you want to win, testing is critical. You know, obviously most Flugtag airplanes never get test flown. So you got to test it. That means you gotta get it done ahead of time. We were a whole week early. The schedule was originally 4 weeks early, but
Nevin's schedule.
for something like this, better is the enemy of done. You know, the saying was Flugtag good enough. But if you really, really, really want to win Flugtag, get a good choreographer. Yeah, I think we clearly won the skit dance part of it. And the other thing that was not planned, but was really worked out well, the yellow chicken suits. Coming up, there's some more video from Long Beach. You'll see what the setup was there. There was 110,000 people. Most of them were a pretty long ways away. Those yellow chicken suits were totally visible to everybody. So this is a Red Bull video, which is a summary of 2013. Last September 21st, they had 5 Flugtags the same day. They were spread around the country. There was Miami, Washington, D.C., Long Beach, Chicago, and Dallas, I think it was. So Long Beach was probably the biggest crowd. That is Long Beach. That's Long Beach.
Bob somewhere.
Heading for the rocks.
There were some other really good craft as you'll see.
Flyers have to jump off, or is that off the road?
It's technically optional. It is really poor form to not jump in. They almost didn't let me jump in because they couldn't find me a clear spot of water because their carpet was so big.
That was actually a pretty good Yeah, that's a canard. They got it together. They deserved their win there.
That was cute.
Chicago had a lot of wind, I think. I mean, you look at that water.
They disallowed some of the really big craft they were afraid would blow away. There was a biplane HPA that was supposed to fly in Chicago that was grounded for the wind.
I don't think they got that done.
No, it's okay.
Notice the CG?
Oops.
I don't think anybody got horribly hurt this year.
Wake up. Okay, I'll leave you two alone.
Going through the weeds.
Getting out of that was probably the sensible thing.
Yeah.
They turned it into a trick contest. Backside when they figured it out.
Celebrity judges.
Now, they actually got to have a bit of a harness
Yeah.
and structure in front.
Cheating does that.
It's time to start launching some craft here.
Nice like a show.
Looks cool. I mean, that's structured, right?
Did your plane survive? Did you get it out of the
There's a
water?
cage.
We could have, yeah.
Before it ever got out to get to the flight deck, you first are you let poop in the news. You know what? Hey, is this real? Yes, it is. There's a new pooper at our workplace.
This one, I think he got hurt, yeah.
Yeah, 14.
Nice little
I think so. If not, I've got another video to see that.
That guy tore his back up really badly. Yeah, there's a lot of blood, but he's okay. Yeah, he was really close to death.
You married me! I love you, baby! That just happened, everybody!
She said yes.
She said yes, and he survived. This thing was gorgeous. The up house.
We never claimed world record.
Did we get there again in the same zone?
We're all pretty tired by the end of it.
Not gonna do it again?
Well, they didn't have one this year, at least in the U.S. And you could do better, but
Chicken Whisperer from Long Beach, California. They broke the world record for Red Bull Flugtag. So they're 58 feet on an Excaliber style aircraft. Amazing work. So hats off to you guys.
Okay, so how many man hours?
We figured that out at one point. I mean, you just work and then you stop your work as soon as you possibly can because you've been thinking about Flugtag all day. And then you go work on Flugtag till midnight or 1 and then you get up and go to work. And then on the weekends you do that except you substitute in Flugtag for work. So then it's just like all day.
And then, when did you do the choreography?
Choreography usually like lunch breaks during work, and choreography was also how people dealt with their nerves before the event. Our pilot just wanted to dance and dance and dance. And it's like, let's visualize the flight. Let's talk about what you're going to do with your wing shift. She's like, I just need to get my moves down. I don't want to mess up the dance. So,
One thing we also did was we met very early on to talk about all the tasks that had to be done. This is the only thing I really did.
Evan's
Just,
a project manager.
Because I manage engineering projects. Just walk through, okay, what actions have to be taken to set out schedule. And no, they didn't meet the schedule, but at least had them thinking about the steps to get to that test flight. And we all, the agreement was that yes, we want to be able to test this aircraft in advance. So that I think is another thing that teams should do is really think through all the steps and try to put a schedule together with some buffer.
I like to share some of the things that could have gone way wrong where I felt like we just were fortunate. We had a Red Bull person walk into our rudder cable. We had a Red Bull person demand that we remove the rudder cable. And just imagine that
the
flight.
rudder cable was a very small Kevlar thread.
Right. And
We
that
didn't tell
was-
them it was Kevlar.
Yeah, that was the only thing that we were worried about the rules on, because they didn't want anything you could get tangled up in. And obviously you can see they didn't enforce it, but so when they came by for inspection, we removed our rudder cables. But then after we put them back on, people were always walking into them, so we had red duct tape dangling from them. We removed that before the real flight, and the Red Bull guy walked into the line and like caught him, yanked the rudder, and it was the rudder Laura used to fly straight instead of veering left into God knows what, and who knows what could have happened. Could have been a horrible tailwind, and we would have probably not flown very far. There were just a lot of instances where we were very fortunate the way things turned out. And I think some of that left us feeling like, wow, we could do this again and do an even better job on the design and then get screwed by some silly little thing. So.
And having done the test flight session the week before, totally paid off. The ability to get the airplane launched was dramatically improved after taking it out and realizing that, boy, this thing really just wants to fall on its ass. So there's a mod to the launch cart to help support the glider better while Laura was running.
And 2 waxed PVC rails, and then a tube that went across the glider underneath the glider's CG, so you could adjust the pitch of the glider with minimal effort as it sat on those rails, right at about this level for Laura. So all you had to do was control pitch and sprint and sort of pull it along, and it just came off the rails and came up under her armpits.
Yeah, if you actually look at Laura's takeoff, there's no way to practice taking off from the cart, because if you think about it, if you come off of the cart and you're doing this on dry land, well, the cart doesn't fall away from you, it keeps going, you're in the vicinity of the cart. Lots of issues for trying to test that. So she started moving down the cart a little bit early, realized she was early and stopped, and then the guys are pushing hard and the cart's accelerating. And when she starts to run again, her feet are already 2 feet in the air.
She didn't get that many steps.
No. So we had about a 5-mile-an-hour headwind.
Yeah, that really helped.
Yeah, it helped, but it also cut the distance. So.
She also told us that she hadn't said ready when we started pushing. There was a miscommunication. There's a lot of noise up there. And then she said she was grateful that she wasn't ready, that she just had to deal with the situation and commit to it at that point.
Well, that was great.
Okay, any other questions? Yeah.
How does that compare with, it takes a commercial hang glider and run it off the edge? How far off is that?
Yeah.
If you try to find commercial hang glider with 200 square feet, they're really terrible LRD, maybe 3 or 4. They don't have airfoils or any laminar flow, and they have exposed everything. If you went with a hang glider that had a lot less area, a high performance one, but if you had a big headwind, you could probably get off and fly away, I think. But if you had no wind, you'd be screwed.
Yeah.
The drop's too shallow to get up enough speed.
That's like we had at the beginning, all of the trade-offs between in the dive and pull-out schemes. Hang gliders normally get launched off of slopes.
Yeah.
It's like a carrier take off with the jets on the Navy, and when they get off that jet, you see that thing go sink, and then they have to really pull up. It's the same concept.
Yeah, although they've got a lot of speed coming.
I know, but when you have no speed, you get that drop.
For the jets, it's more, they just have more distance to accelerate in.
Yeah.
The speed advantage they get by losing the altitude is nothing.
Yeah, but the only part I'm realizing is when you run off the edge, you get that initial gravity pulling it down and drop. And
Scary.
It's scary, and when you're trying to just manpower with the aircraft and trying to make everything work aerodynamically, so yeah.
There's a competition where they allow hang gliders, and the guys routinely just bring whichever hang glider they own or bought for it. And then it's just about pilot skill and weather. And that's in England, or it might be Australia, but if you look around YouTube for that, you should be able to find those videos. And I don't know how they get out of their harnesses and not drown. Yeah, there's a special rig for that.
All right.
You guys set a high bar.
Yeah,
that's true.
Use
yeah.